Hey, Andy here. Got an interesting comment on the Rancher Users Slack channel under Harvester from the third party CSI driver support that I posted about the Pure Array and Portworx and all that. One of the questions is they were asking about, does this also apply for the NFS CSI driver? This is the generic one that comes from the Kubernetes upstream. And so I figured I'd make a video. Oh, sweet, background just switched. I figured I'd make a video, show you how it's deployed, what it looks like, and kind of go from there. Cool. So in the show notes, I'm gonna put in a link to this gist. That's kind of a nice way to do it. And it talks about using the generic driver. There's docs here if you want to go follow it. What we're going to do in this video is we're just going to go ahead and install it, and we're going to test it with an NFS server running on a different Harvester node. Yet another Minas Forums NUC. Call me. Still waiting for that call. Would love to get a couple of MSA2s when they come out, or a couple of MSA1s. Long story short. So let's go ahead and get in the install. And just to show you, I've got on 1.12, I've got my little slim NUC. And right now I've just got a couple images configured, and it's all local storage. We can go into storage classes. You can see I don't have any of the storage classes set up. And the VM I'm getting it from, the NFS server I'm getting it from is 178. So this is running on a different NUC in the other part of my house. And there's like a 2.5 gig network between the two. So let's go ahead and get this installed. And what we'll do is we'll go ahead and run this. So according to their docs, there's two ways to install it. There's a couple ways to install it. You can clone the repo, you can curl pipe bash it, or there's even a Helm install. I'm just going to curl pipe bash it because why not? And we'll wait for those to come up. And it does take a minute to download. By the way, I've been pixie booting these Harvester nodes, this same Harvester node, just so I can kind of rinse and repeat and test and rinse and repeat. Because uninstalling it might not have cleaned it out, so I've had to rebuild this a few times just to make sure it works. No big deal. Okay, while this is coming up, just kind of point something out. The reason why I don't have a goatee right now or facial hair, I was playing firefighter yesterday, driving the engine around, doing some drafting and refilling water tanks. So that's kind of fun. Hope you had a good weekend yourself. Let's go ahead and close that out. Let's go ahead and talk about the next step. And it's actually relatively easy, right? So it's install the driver. Then it's add a storage class. And by the way, we're also going to add a volume snapshot class. Now, the thing to pay close attention to is in that storage class is where you designate the NFS server and the mount point. Keep that in mind. Now, I've already gone just to show you. Here's my NSS, right? Here's my NFS file system being exported from a VM. This would absolutely apply to like a Pure Array or any other type of storage array, Synology, TrueNAS, things like that. As far as Harvester is concerned, I don't think NFS is going to be as performant as iSCSI. And it has to do with how it has to copy the volume, do a volume snapshot, and then copy it back to the storage, right? So the NFS in this case, VM versus an array. So it does take some time to work. So just keep that in mind. So, and I'll show you what that looks like in a second. So we've got our storage class. We can kubectl get sc, and we can see, oh, I haven't created it yet. So let me go ahead and create that. Go ahead and create our storage class and our volume snapshot. Once those are created, we can get sc, and now we can see the NFS CSI is there and configured. Now, one of the steps in, you can see right there as well, one of the steps in the Harvester documentation around that third-party driver was to go into the settings and actually configure it. So we're going to scroll down until we see CSI driver config. We're going to go click edit, click, add, and we should have a new provisioner here and a new snapshot class. We can go ahead and hit save. Okay. Once that's done, we can go to images, and what we'll do is we'll actually download. I've just kind of scripted it just because it's easy to do a kubectl apply for a virtual machine image, and we'll go ahead and apply that and come back to Harvester, and we can see that it's already downloading. Now notice it's only like 235 megs. We can do a kubectl get pvc, and we can see that we actually have two that are pending. So what it actually does is it copies it down, writes it to the PVC, and then closes it out effectively. And so you'll see when this is done, we'll go back here to the meter, and it's at 0%. So we're waiting for the download to start. And once it's done downloading, we'll see the PVCs go back to only 2. We'll give it a sec to do that. It has to do with how it's storing the VM image. And one thing to keep in mind is that these images have to be on the file system you want to deploy VMs to because of that snapshot cloning process. So in other words, I have 3 images here. I've got Rocky 9.4, I've got Ubuntu Noble, and I have one on the NFS. But because they're different storage classes, this will make sense in a second. Let's go ahead and call it demo. Oh, sorry, we're not doing an image. We're doing a virtual machine. Let's go ahead and call it demo. I'm not going to use a template because that system's broken at the moment. And I'm going to pick my default SSH key. Pick the size of the VM you want. Let's go to networking, VLAN 1. I don't really care about any of that stuff. The volume. Notice for the volume, this will designate which storage class is going to be used for the VM. So Harvester Longhorn, or NFS Ubuntu. And make this, it's not a very big file system on the other side, on the other VM. So I should make it 20 gigs. We're going to hit create. So if we go back to PVC, we can see that we have an NFS Rocky mounted. Okay, so it's bound, I should say. That's the one coming from that other NFS server. Let's say 5. We'll watch that for a second. And this will take a second to come up. Notice it's in a pending state. And we'll watch it for a second. The other thing we can do in terms of troubleshooting, and I put this in here. Oh, I didn't. I got to add it. But there's a troubleshooting link. Let me see if they had it hanging here. CSI driver example. I'll have to find it. But it did have a troubleshooting set of docs that would allow you to... Is it here? I don't see it. I'll find it in a sec. Actually, I know where I have it. I have my VS Code. And I put it down here because I didn't add it in. Here, I'll update the gist in a minute. But here, let's copy that. So one of the interesting things about the troubleshooting page, the debug tips, that's right, it was down in 4.11, I think, whatever. But one of the things it does talk about is actually getting the logs from the CSI controller. And this will show you it does that copy and mount. Okay, there we go. So it just copied the temp PVC. We'll go back here. So it says it's running, and now it's bound. So it did that copy, and like I was talking about, and we can see it starting up the journal service, and there we go. Now we're into it, and I don't remember the root password. Let's see if I think my key automatically gets injected, so it should be SSH. Let's try root. Please log in as Ubuntu. Okay. Cool. So quite literally, because I don't have that APK. Sorry, so many different operating systems. Something's getting installed. Oh, duh. Apt install. Boop, boop. So quite literally, we have Ubuntu running as a VM on one Harvester node through the NFS CSI driver talking to a second NFS node. And if we're curious what that looks like, because it's actually kind of interesting. We're connecting to the node. We can see the PVCs. Now I've got a few in there that I was playing with today. But if we do a du minus sh, we can look at the size of the directories. Notice one is 4 gigs. Okay, so you can see. In fact, actually, this is kind of cool. Quit out of this. kubectl. I forgot I was double in there. So you can see the two PVCs is 772 and F2C. 772 and F2C. So if I really wanted to, I'll clean this up. Cool. So you can see there are two PVCs on the NFS file system on that other VM. So this does work. Not too bad in terms of setup. I was able to do it in a minute or two. Not exactly. I wouldn't say it's exactly the most performant, but it is completely capable of working. Now, I think where it really starts to get interesting is the TrueNAS or Synology or QNAP. There's a handful of other storage appliances out there. Is it going to be the most performant? Actually, I'm going to say no. Only because on this node, I've got an NVMe device. And just to kind of show you, we'll call it local, just to kind of show you the speed for which these VMs can actually get created. And it does that copy on a local file system. Noble, apples to apples, and we'll do it VLAN. And you can see how quick it is on schedule, depending to running like within seconds, because that NVMe locally is going to be much faster individually. Where I think the NAS really kind of comes in is when you start talking about a cluster, when you start talking about hundreds of VMs, 10, maybe 10 to 20 VMs, hundreds of VMs, you're going to get a lot more performant at scale, where a single NVMe you're going to wear out quickly against, on with a bunch of VMs, especially if you're starting and stopping and starting and stopping. It's not going to be able to deal with the overall pipe, the overall bandwidth, if that makes sense. Because like there's speed, and then there's how many of those you can do at the same time. Think of it like a highway. The Autobahn is three lanes, can't carry as much traffic as a 6-lane, an 8-lane highway. And that's really what we're talking about, is using those NFS enterprise devices as a much wider 8-lane highway versus a really fast 2-lane road. Right? You can see that took no time to spin up. Hope you found this helpful. And again, if you got any questions, comments, concerns, feel free to reach out. And it was fun playing. Have a good day. Bye.